Go outside on a clear night and look up. You will see a scattered canopy of a few hundred to a few thousand stars. For thousands of years, humans looked at this view and assumed they were seeing a sparse, lonely neighborhood. To see what is actually around us, we have to map the space. This 3D map scales out to exactly 20 light-years from Earth. Inside that relatively tiny bubble, there are more than 130 stellar objects, packed into 94 separate systems. The neighborhood is crowded. But watch what happens when we filter this map for the stars you can actually see with human eyes. Everything else, more than 100 objects, disappears. Those missing stars are not hidden behind dust clouds or distant nebulae. They are simply too faint. In fact, the closest star to Earth sits right next door, and nobody in the entire history of our species has ever seen it without a telescope. The sky you have been looking at your entire life is an optical illusion. It actively hides the reality of where we live. For almost all of human history, a star was just a point of light, and a light tells you absolutely nothing about its distance just by looking at it. The natural assumption was that the brightest stars in the sky were simply the ones closest to us. That assumption held until the winter of 1838, when a Prussian astronomer named Friedrich Bessel finally caught a star moving. He proved that humanity could actually measure the physical gap to another sun. This diagram illustrates his method, called stellar parallax. By observing a star from one side of Earth's orbit and then waiting 6 months to observe it from the other side, a nearby star will appear to shift slightly against the distant background. The problem was the sheer scale of the void. The shift Bessel measured was roughly the width of a human hair seen from a football pitch away. Proving the massive gaps between stars required specialized, hand-built instruments just to see the movement at all. Bessel calculated a gap of about 10 light-years. Once humanity had a reliable ruler for the cosmos, we realized that proximity and visibility have almost nothing to do with each other. The objects physically closest to Earth were entirely invisible to us. Take the first star on our street, Proxima Centauri. It is about 4 light-years away, closer than anything else outside this solar system. But it sits at an 11th magnitude of brightness, radiating almost all of its energy as invisible infrared heat. Proxima is a red dwarf. These are small, cool stars. Because of their internal structure, they lack a stable boundary to organize their magnetic fields, making them tightly tangled and highly volatile. Because a red dwarf is dim, its habitable zone is drawn in tight. A planet orbiting there is pulled so close it becomes tidally locked. One side cooks an endless noon, the other freezes an endless midnight, and the star routinely unleashes massive ultraviolet flares that bathe the entire planet in radiation. These stars are incredibly stealthy. Barnard's star is crossing our neighborhood faster than almost any other object in the sky. In 10,000 years, it will take the title of the closest star to the sun. Yet it is so dim that no human eye has ever registered it passing by. This chart lays out the local population. Out of roughly 100 main sequence stars within 20 light-years of Earth, about 80 of them are red dwarfs. The stars you see at night are the rarities. A statistically normal star is a small, invisible, flaring red dwarf. The local census gets even darker. We also have abandoned houses on the street, white dwarfs. These are the exposed cores of massive stars that ran out of fuel, shed their outer layers, and are now slowly cooling as dead cinders. Within 20 light-years, there are 6 of these stellar corpses. They have already lived their entire lifespans and finished, sitting in the local dark while our sun is barely halfway through its own life. Then there are the brown dwarfs, objects that formed out of collapsing gas, just like stars, but never accumulated enough mass to ignite ordinary hydrogen. They sit warm from their own formation, fading endlessly in the infrared. They are so completely hidden from us that the third and fourth closest systems to Earth are brown dwarfs discovered in the last 12 years. One of them is barely warmer than a winter night in Chicago. When you total up the neighborhood, the vast bulk of our immediate universe consists of the violent, the dead, and the failed, and we cannot see a single one of them. Now compare that hidden population to Sirius. Sitting about 8.5 light-years away, it is the brightest point in our night sky. It is massive, white-hot, and young. Sirius is an extreme outlier. Within 15 light-years of Earth, it is essentially the only star of its kind. This scatterplot compares the distance of nearby stars against how bright they appear to us. Human vision only operates above this strict threshold. The sky we observe is curated entirely by a star's brightness, capturing only the extreme outliers at the very top of the graph, while ignoring the densely packed reality below. Humanity's historical picture of the cosmos is a flawed dataset built entirely out of rare exceptions. We selected our view of the universe based on rarity. Looking back at our demographic grid of 103 ordinary stars, there are exactly 3 yellow stable stars in the entire volume: our Sun, Alpha Centauri A, and Tau Ceti. Every baseline assumption we make about what a habitable world looks like, a bright, stable star with a wide safe zone, and a regular day-night cycle, comes from standing on a statistical anomaly. A mathematically typical inhabited world sits in a very different sky. It is locked in an eternal twilight ring, bathed in the glow of a massive, dim red sun that never rises and never sets. Our entire perspective is skewed. We are observing the normal universe from inside a freak cosmic anomaly, drawing conclusions about the galaxy from a sample of one.